Good evening and welcome to Leeds University Business School for this evening's Corporate Wisdom event and the Professor Chris Clegg Memorial Lecture. I'm Mark Robinson, I'm an Associate Professor here in the Business School, and I'll be introducing our excellent speaker, Dave Knott, very shortly. Just a couple of bits of housekeeping for you. The nearest toilets are out in the foyer just here. The nearest fire exit, hopefully we won't need it, are also in the foyer just over this direction here. There are also refreshments in the foyer after the lecture from 7:15 until 8, so do please come along and mingle and chat to people. Also, if you have signed up for tonight's lecture online, you will now be on our mailing list. So we do have an exciting series of events and a calendar for the year ahead, so do please come back. We love welcoming external visitors. Tonight's Corporate Wisdom event is a particularly special one because it's the Professor Chris Clegg Memorial Lecture. Many of us here in the audience tonight knew Chris very well, and it's wonderful to see so many of his ex-colleagues, students, friends, and family members here this evening. Chris was a Professor of Organisational Psychology here in the Business School until 2015. He was one of the most influential organisational psychologists in the UK and internationally renowned for his research in the areas of socio technical systems, job design, and the human aspects of information technology. He published well over 100 journal papers, book chapters, and books in these areas. And he also launched countless careers. There's many of us here in this room today would not be where we are in our careers and our lives without Chris's influence. And it's certainly his wisdom, his warmth, and his wit are sorely missed by all of us. In terms of one of the key aspects of Chris's sort of research philosophy, if you like, was his willingness and his desire to engage with both other disciplines and also external organisations. And the best example of this was Chris's research with Rolls Royce and that of his team. And certainly this is the one he was proudest of. It stems right back to 1998 at the University of Sheffield and continues to this day at the University of Leeds. And fundamental to this relationship right from the very start was tonight's speaker, Dave Knott. Dave's been a real champion of our research in Rolls Royce and more broadly, and we're delighted he's here this evening, as I know Chris would have been also. A little bit of feedback, sorry. So Dave has just recently retired following a distinguished 39-year career in Rolls Royce, where he rose to Chief of Research and Technology for Design Systems Engineering, where he oversaw a global network of specialists developing tools, products, and processes for Rolls-Royce's engineering design processes. A key part of his role was also facilitating the relationship and partnerships that Rolls-Royce had with various universities, including ourselves here at Leeds. And although an engineer, Dave is heavily interdisciplinary, so he has a fantastic knowledge of other disciplines. So, for instance, he was instrumental in recommending that we use computer simulation techniques and to apply that to human behaviour. He was also familiar with the Pomodoro technique, for instance, would often send me Harvard Business Review papers first thing in the morning that I then have to research and look up. So, fantastic knowledge to do with organisational behaviour. So it's fantastic to have Dave here this evening. The second half of Dave's career really focused on innovation, so managing and implementing innovation in Rolls-Royce of products, processes, and tools. And I can't think of anyone better to talk about innovation. As well as his extensive practical experience, Dave also has 20 patents in the area of gas turbine aero engine technology. And he's also published multiple scholarly articles and academic papers. So not only does he talk the talk, he also walks the walk. And we're absolutely delighted to have him here this evening. And I'm going to hand over to Dave now without further ado for the lecture. So thank you very much. Dave Knott.
Wow, thank you very much, Mark. Very, very kind words. I wanted to start by just saying how honoured and humbled I felt, actually, to be asked to give this lecture in memory of Professor Chris Clegg. As Mark said, I first met Chris in 1998. And, you know, Chris being this internationally renowned professor of work psychology, I mean, you just wouldn't know it when you met him. Chris was, he had many warm characteristics as an individual, and the two that made a lasting impression on me actually were his warmth and his humanity. And again, Mark has already mentioned that. And these combined together to make someone who was very humble and very unassuming. And I think he was the most humble and unassuming person one of them that I've ever had the privilege of knowing. But the occasion of my meeting Chris was the launch of something called the University Technology Partnership in Design, or the Design UTP. And this was a partnership between Rolls Royce, BAE Systems, and the universities of Cambridge, Sheffield, and Southampton. And it was a partnership that was based on the very successful Rolls Royce UTC model. And I was the Rolls Royce lead. Chris was the professor who was directing the work on human factors and innovation. One of the key reasons for the success of this partnership, which was very fruitful from our perspective at Rolls Royce, was the quality of the relationship between the directors. So you had Chris as the director from Sheffield. You had Ken Wallace from the University of Cambridge, and Andy Keane from Southampton. Ken, he directed the work on engineering knowledge management, and Andy Keane directed the work on design search and optimization. And the way the directors worked together was, as I say, a big success factor in that being a fruitful partnership. Those of you who worked as part of Chris's team will know this already, but one of the things that Rolls-Royce and I really appreciated about Chris as well was his ability to bring a good team around him. And those of you who were part of that team, part of his team that worked with Rolls-Royce, are a living testament to that fact. So thank you for that. Now, the nature of Chris's involvement, with people, of course, not much happens in engineering or any other field for that matter without people. And so the work that Chris and his team covered at Rolls-Royce was very broad. It included creativity and innovation, but also implementing IT systems and organizational change, complex systems, trust, the competencies of design engineers, very important discipline, because I was one at one time, team working, workspace design, and process compliance. And I also very much remember his work on vicious and virtuous circles in new product introduction being very influential at senior levels within Rolls-Royce. Chris also introduced the term Socio Technical to Rolls-Royce and some of the thinking that went with it, so that we started to see our organization and our processes as socio-technical systems. He liked to remind us as well, as often as he could, that our systems thinking about our products was much more mature than our systems thinking about our organization and our processes. And he also kindly added, that we were not alone. He, more than most, understood how hard it is for many organizations to get this area right. He did make an outstanding contribution in his field, and I was very pleased to see that his work with Rolls-Royce on socio-technical thinking was assessed as outstanding in terms of reach and significance by the 2014 research assessment exercise. A very worthy assessment. And the innovation process that I want to talk to you about tonight is an excellent example of a socio-technical system. And so what I want to cover with you tonight is really to touch on why I see innovation as a contradiction, to present to you an innovation equation and a change equation, and to show how they can be combined together into a tool that I've called the 9 windows of innovation. I also want to introduce to you the concept of innovation playing fields, and then finish with some conclusions. But first of all, let me explain as well where I'm coming from in the things that I want to share with you tonight. These are really observations and they're lessons from my 39 years at Rolls Royce, who, by the way, make aero engines and other power systems. They don't make cars, which is a very understandable assumption to make. But from being an undergraduate apprentice through to being a senior manager, my whole working life really has been around innovation in one form or another, whether as a design engineer or an inventor or an innovation leader or as a manager of R&D. You know, I did take early retirement from Rolls Royce last year, and it's been really good to step back a bit and think about what is it that I've learnt over that time, and the privilege really that I've had working for a company like Rolls Royce that has innovation written into its DNA. So, why do I see innovation as a contradiction? Well, a contradiction is defined as a combination of statements, ideas, or features which are opposed to one another. And in my experience, innovation is like that. You know, for example, innovation has opposing motivations within organizations. Organizations want to innovate to stay ahead of the competition, but on the other hand, they don't want to change anything because change is costly and it's risky. The Innovator's Dilemma, which is a book that's been described as one of the 6 most influential books on business ever written, by Clayton Christensen, describes the dilemma faced by organizations, especially market leaders. It describes how difficult it can be in choosing where to invest in the short term or the long term. And this is another contradiction within the innovation process, the contradiction that it creates between short-term thinking and long-term thinking. And, you know, this is a memorial lecture, so I thought I'd also throw in that Christensen also wrote a book called How Will You Measure Your Life?, which is also very full of insights. But innovation also has different needs as you move through the process. You know, the characteristics that get you on the path to innovation are pretty much doomed to failure further down the road if you stick with them. It has different needs, and from their research into innovation, Perry Smith and Manucci describe the effect of these contradictions. They say, these seeming contradictions suggest a number of paradoxes that ultimately highlight why successful movement through all phases may be a rare and difficult occurrence. So, how do we solve the innovation contradiction? Well, a good place to start is to try and really understand in a holistic way this paradoxical and socio-technical process. So I want to introduce you to an innovation equation. Now you'll find a number of innovation equations on the internet, and they all have valuable insight to offer. But if we define innovation as the generation and implementation of new ideas, then here is mine. Innovation equals creativity times knowledge times project management. I'll cover each element in more detail, but I want to point out, first of all, that this is a multiplying relationship. It's not an adding relationship. So what that means is that, you know, no matter how much creativity and knowledge you have, if you don't have the right project management in place, your innovation is likely to be zero. What this also means as well is that your ability to innovate will be throttled by your weakest link in this chain, whether it is creativity or knowledge or project management. So, let's look at creativity first of all. Now, creativity is pretty universally seen as essential in problem solving in general. Most innovation equations you come across have creativity explicitly in there. And most problem solving techniques or process improvement techniques somewhere along the line will have something like generate ideas as part of their process. But most don't give you much help in doing this. Of course, there are the techniques out there that are very common, like brainstorming and lateral thinking. But even so, one of the frustrating things about creativity is that it seems a random process. The brain seems wired to make it that way. We're not thinking about a problem and then all of a sudden a solution will pop into our head. And the other common observation about creativity is that some people just seem more naturally creative than others. And this begs the question, are we stuck with the level of creativity that we have now? Well, I've come to the conclusion that the answer on both of these questions is no. I've had an interest in creativity and innovation for a long time. I think it was one of the things that attracted me to engineering in the first place. But some 20 years ago now, my wife actually spotted an advert for a lecture at Loughborough University that was called The Theory of Inventive Problem Solving. This was intriguing to me. So I went along. And the lecturer was a guy with a thick Russian accent. But the more he talked, the more excited I became. Because it seemed to me that what he was saying about how to create inventive solutions to problems was so powerful and yet so simple. I was leading a design team at the time, and we were grappling with an advanced engineering project and a problem that was being caused by centrifugal force. Now, you have a lot of centrifugal force in a gas turbine. But what I said to the team, I said, look, I went to this lecture last night by this Russian guy, and he said, when you're solving a problem, try to use the thing that's causing the problem to be the source of the solution for your problem. So we took this concept and we came up with some ideas. One of them in particular seemed pretty interesting, so we worked it up, we tested it, and we were able to file a patent on it. So from that moment, I was pretty sold on this theory of inventive problem solving thing. And when later I became responsible for improving the design process in Rolls Royce, I was keen to investigate this theory of inventive problem solving some more. And actually I finished up championing it within Rolls Royce for 10 years. What's the name of this methodology? Well, it's called TRIZ. TRIZ comes from the Russian acronym for the theory of inventive problem solving. It was developed over a 50-year period and involved analysing more than 2 million patents. And as such, I think it's the biggest study into creativity and invention that's ever been done. Now, at the time, Oxford Creativity helped us introduce TRIZ to Rolls Royce. And since retiring from Rolls Royce, I've been working with Oxford Creativity in facilitating TRIZ in problem-solving workshops. And there's something very rewarding, personally, in helping companies come up with innovative solutions to real problems. Now, the key findings from the TRIZ research were these, that first of all innovations emerge from the application of a relatively small number of inventive principles and strategies. For example, it blew my mind as an engineer to think that actually all the problems I might face can be solved by one of what Tris calls 40 inventive principles. That seemed to be a very small number to cover all the fields of engineering. One of my favourite principles, actually, is principle number 13, which is called the other way round. And this problem was applied to a software problem in which we were trying to automatically calculate a complex aerodynamic parameter. But the software kept falling over when the geometry changed. And we were working on this for months and decided we needed a different approach. So we turned to Tris and used the 40 principles to generate ideas. And when it came to the other way around principle, that generated the idea of, well, rather than create a solid model of the metal that's forming the air passage, why don't we create a solid model of the air itself? Which we did, and that solved the problem. Another finding from the research was that technical systems and technology evolve along highly predictable trends. Another, that the strongest solutions minimize the introduction of additional resources into a system and maximize the use of what's already there, even the harmful elements like centrifugal force, going back to that example that I first had. And this is what makes Tris, I think, so effective at producing simple, low-cost solutions to problems. And another finding was that the strongest solutions eliminate the conflicts and trade-offs. Tris calls them contradictions that exist and are often assumed to be fundamental to a design or a technology. So, how does Tris work? Well, in conventional problem solving, we try to go from our problem to a solution in a direct way, but often there's something stopping us getting the kind of solution we really want. Tris takes a different approach, because what Tris does, it gets us to think about a problem and abstract it into a conceptual problem that the world has solved before. From that conceptual problem, we can make a connection to the world's best conceptual solutions to that problem. And we can then use those conceptual solutions, like the 40 inventive principles, to trigger solutions to our specific problem. And this is a systematic process. And the systematic nature of Tris, I think, is one of the reasons that I think it appeals to engineers so much. One of our senior engineers used to say that he thought Tris also gave our engineers permission to be creative. You know, sometimes engineers need permission because it's not in our training necessarily to do that. Systematic and creative aren't words that you normally associate together, but in my experience, Tris actually is both. And in the engineering field, there is a technology called knowledge-based engineering, or KBE. And this is a technology that embeds knowledge into geometry models so that you can quickly and even automatically adjust that geometry to new requirements. And in the same way, I see Tris as enabling knowledge-based creativity. And from that, we get better ideas faster. In 2003, I wrote an article entitled Tris in Practice, Better Ideas Faster, for the Chartered Institute of Patent Agents journal. And there I used the graph shown here to really illustrate this effect. So this was the results from an initial valuation of a problem-solving session where to solve a design problem. And we did the session in two parts. We did a conventional brainstorming session, and then we did a Tris facilitated session. And when we did the analysis afterwards, it showed that 75% of the ideas that were generated as high benefit and high feasibility came from the TRIZ workshop. And information like this is very useful when you're trying to encourage the use of a methodology like TRIZ in a large organisation. Evidence like this is good. Personal conviction and experience are good. But does the benefit of TRIZ stand up to scientific scrutiny? And what are the long-term and short-term effects? Well, I'm very grateful to Kamal Birdie and Des Leach and Wissam Magadli for their paper in R&D management, in which they report a longitudinal study. It was conducted over about 3 years, and it compared engineers who had been TRIZ trained with engineers who hadn't been. There are a couple of quotes from the paper on the screen, but I'll just read you their final paragraph. It said, in conclusion, this study demonstrated that TRIZ-based creativity training can improve both creative problem-solving skills and motivation in the short term, and contribute to improved engineer creativity in the workplace over the longer term. Although evidence for the better implementation of these ideas into innovations as a result of the training was more variable, enough idiosyncratic examples were given to justify the costs of running the program as part of an R&D function. Now, this sort of evaluation is rare. It takes a lot of resource and a lot of effort. But I was very pleased with the conclusions and more than a little relieved, having championed it for 10 years, that it seemed to have paid off. The evidence for improved creativity was strong, but the evidence for more implementation of ideas was variable, which I think is very fair. It's a very fair observation. And, there's a lot more to innovation than just creativity, and which is, why there's more to the innovation equation than just creativity. Knowledge. Knowledge is the second variable in the innovation equation. Knowledge and understanding are vital elements of any business process, and innovation is no different. You need knowledge to know the right questions to ask, let alone the right problems to solve. I'd been a graduate 9 years when I produced my first high-value invention that's flying around today. It's called an annual spiller. There's a picture from the patent on the screen. The point was, I suppose I'd been around long enough. I'd solved enough problems. I'd seen enough issues, and I suppose critically in this case, I understood enough about the previous design to know there must be a better way. And the new design was fundamentally different, and as a result, it was considerably lighter and cheaper than the previous design. Knowledge is essential as well when it comes to evaluating ideas and improving them. Evaluating and rejecting ideas is a vital step in the innovation process. But your innovation can also trap you into psychological inertia. Experts can get good at telling you why something can't be done. This is why it's so important to suspend judgment at the start of any creative activity. Judgment and knowledge will be needed, but it needs to be applied at the right time in the process. History shows us the amazing and disruptive things that people can achieve when they don't know it can't be done. I think we're living through an event right now with the electric car revolution that's rather like that. The other vital element of knowledge, actually, is learning. We must know how to learn. There is a phenomenon that's intrigued me for quite some time called learning curve. It was observed first in the 1930s when they were studying the manufacture of aircraft. What they found was that as the number of aircraft that they'd made doubled, the cost of those aircraft came down by the same percentage. And this phenomenon has been studied widely since then and found to apply to many product attributes, not just cost. It's also been found to follow an inverse power law. Now, my view on this is that, if you are manufacturing a fixed design, then the only product attribute you can really influence is cost. But if you look at this from the point of view of design, the number of design iterations you go through, the number of designs that you actually produce for a product, then during the design process, all the product attributes can be improved through learning curve. And learning curve begs the question, can we learn faster? Because if we can learn faster, then we can innovate faster. Well, in the learning curve equation, the exponent is the learning rate. And as the graph shows here, if you double the learning rate, then you double your rate of improvement, even though you start at the same point. McNerney et al., they produced a very interesting paper, to my mind, where they actually mathematically modeled the learning curve phenomenon in complex systems. And from their analysis, they found there were two ways of increasing learning rate. The first was to make it easier to improve components in the system, which is, perhaps to be expected. But the second, more unexpectedly, they found that to improve learning rate, you needed to reduce the system complexity. Now, it seems to me learning has got to be a very socio-technical process, because one person needs to pass learning on to another. One team in a large organization needs to be able to pass learning from one team to another. And I'm sure there's been work done on learning curves from a socio-technical perspective. But, I would encourage you who work in that field to look into this some more, because it feels to me like we need help, and it could have a big effect on the way we learn. And there are a number of implications that flow from this. And I just want to underline the first and the last here. So the first thing is that learning curve, I think, is innovation in action. It's largely evolutionary in nature very often, but, it's still very powerful. Improvements happen when people get some learning and they get an idea on how to do it better next time and implement it. But the second thing about learning curve is also very interesting. The fact that learning curves imply that stability is very desirable and instability is very expensive. Learning curves suggest that, to me, that the best team to design your next product is the one that designed the last one, because they've got all the learning in their heads already. When teams get disrupted by reorganizations or process changes, then learning can get disrupted, which is expensive, because it means that you won't get the improvement that you would have got if you had left things alone. And I think this is part of the hidden cost of organizational change. It's also a powerful driver of some of the contradictions within innovation. We want to improve the organization and we want to improve the processes. How can we improve them if we don't change them? But if we change them, we might interrupt learning curves. And as a result, lose out on improvement that we would have had. So we need a better way, I think, of predicting the effect of disrupting learning curves, so that we can redesign organizations and processes with a full knowledge of what we're doing. Disrupting learning curves should not be done lightly, which is why very often when you get a disruptive innovation, these are best developed away from your existing products, even in a separate business unit, so they don't disrupt the learning and the improvement of your ongoing products. The third variable in the innovation equation is project management. Now, this might be a surprise to some of you. It's not common for project management and innovation to be talked about perhaps in the same sentence, but in my experience, project management is absolutely vital for innovation of any complexity to succeed. I finished my career at Rolls Royce managing a team of global program managers, and I'm an engineer. Most engineers have to do some level of project management to make their job work. But I developed a great respect for good project managers who could make things happen. The implementation part of innovation needs people who can make things happen. And when you think about it, project management has to be, again, another highly socio-technical process, because you make things happen through people. So what do I mean by project management in the context of innovation? Well, here are 7 elements of project management as they can be applied to an innovation process. I just want to draw attention to number 7. Maintaining good communication with all the stakeholders from beginning to end of the innovation. In 2002, 2 former colleagues, John Kelly, Steve Weisel, and I published a paper called Effective Technology Transfer in Rolls Royce, the Practical Assessment of Business Benefits. Now, in this paper, we presented a model of technology transfer that was characterized by 2 key elements: acceptance and assimilation. Assimilation covered the sort of mechanical aspects of ensuring research outputs get integrated into a company's processes and systems. But the harder and arguably more important element was acceptance. And acceptance is about winning over the hearts and minds of key stakeholders. We didn't call the role responsible for achieving this a project manager, but that is what they were. We called them UTC coordinators because they acted as the key interface between our technology centres and Rolls Royce. And I know from personal experience, how hard and vital this role is. But I think it's a good example of how important project management is to not only technology transfer from academia into industrial application, but really to the success of any innovation. As part of this work as well, we also measured the business benefit from research investment, which happily was considerable. But here's the thing, it turned out that the statistically most significant factor that predicted business benefit from research was not things like the amount of research funding that was made available. It was actually the amount of informal contact between the researchers and the intended users of their research. And to my mind, that's a very significant, as well as socio-technical, insight. Okay, so we've looked at an innovation equation. Now I want to introduce you to a change equation. Sorry for all the equations, I'm an engineer, I can't help it. But like the innovation equation, the change equation is made up of three things. It's made up of capability, motivation, and opportunity. And again, it's a multiplying relationship. You know, it doesn't matter how much capability or opportunity you have, if you don't have the motivation, then the business benefit from your change is likely to be zero. Now, capability, I think, is fairly obvious. So it includes things like skill, knowledge, tools, and I'm sure we'd all recognize the importance of motivation. I do, though, hear a lot of talk about lack of bandwidth in organizations, not having the time to do what needs to be done. And I think it's vital for leaders to create the opportunity for change. And so it is with leaders of innovation. So what I want to do now is introduce the tool that I think will help us try and solve the innovation contradiction. It's called the 9 Windows of Innovation. In the TRIZ 40 inventive principles, they're aimed at solving contradictions. And principle number 1 is called segmentation. We can solve a contradiction by segmenting the problem. And the 9 windows of innovation enables us to segment the innovation contradiction. Each window is a combination of a variable from the innovation equation and the change equation. As with the equations, each window is a vital part of the process. You know, if you don't have the opportunity to share your knowledge, then you're likely to get very little benefit from an innovation. And we can use this tool in 2 ways. So the first way is to help capture, in a holistic way, the current state of our innovation process. What are its strengths? What are its weaknesses? We can use each window to focus our thinking and ask questions like, what is our capability to be creative? What is our opportunity to use our existing knowledge and develop new knowledge? And the second way we can use it is to generate ways of improving our innovation process by suggesting ideas to improve each window, especially the window where we're weakest. So, for example, I've talked about TRIZ. TRIZ training, it will increase your creative capability, and as Birdie et al. Observed, it will also increase your motivation to be creative and to innovate. Since TRIZ is also a knowledge-based creativity tool, it also enables you to access a distillation of the world's knowledge around problem solving. Problem-solving workshops are a good way of creating the opportunity to get your teams to be creative and to share their knowledge. Aiming to be a learning organization, to maximize your learning rate and your capacity to improve. Partnering with other companies, and in particular with academics, is a good way of broadening your knowledge base. I've managed a range of collaborative research projects, and as long as you can keep the overheads in control, then they are an excellent way of increasing your knowledge base quickly and cost effectively. This is one of the reasons why government funds collaborative research. It recognizes that it's often at the interface between knowledge domains that breakthrough innovations are born. Creating roles with defined responsibilities for the project management role is a good way of making sure that you're creating the motivation and the opportunity for that project management activity to actually take place. Perry Smith et al., they talk about phases in the process of idea championing and idea implementation, which is all part and parcel of that project management part of the innovation equation. Now, as I've thought about my experiences around innovation, it seems to me that there is another way to segment the innovation contradiction. So I want to introduce to you another tool called innovation playing fields, to try and really explain why some innovations are way, way more difficult than others, and what we can try and do about it. There are 4 innovation playing fields, and they're characterized by one variable from the change equation and one variable from the innovation equation. The variables are organizational motivation and organizational knowledge. So I've combined these into a 2x2 matrix, and it defines 4 quadrants. And I've chosen these axes because it seems to me that at some point or other I've been in each one of these parts of the innovation space. And the characteristic of organizational knowledge and organizational motivation seem to give a good differentiation between these different types of innovation. So the first type of innovation is also the easiest, okay, where the organizational motivation is high and also the organizational knowledge to implement innovation is high. I've been in a situation like this, where the organization recognizes there is a problem and they're committed to solve it, and the knowledge around you to solve it is also high. It will never be perfect because any innovation is going to involve doing something new, but it's not too much of a stretch from a knowledge perspective. Problems in new product introduction can often be like this. If the problem is big enough, the organization will throw resources at you to fix it. I think it's a very true saying that necessity is the mother of invention. From my experience, I also think necessity is the mother of innovation as well. The next type of innovation is not quite so easy, but it's still relatively easy. And that's where the motivation is high, but the knowledge in the organization is low. The good thing is that as an inventor or an innovator, the organization gets it. They will provide resource to you to move this forward. And again, I've been in this sort of situation, where there's a bold vision, for example, and it's got senior approval. And so getting things like funding and resource are relatively easy. But even so, it is a bold vision, it's a stretch, it's a disruptive technology. The knowledge within the organization of how to get there is low. The third type of innovation is harder. Because although the knowledge might be high, the organizational motivation is low. Process improvement is often like this. I've been there too. You know what needs to be done, but the motivation within the organization to take it on board is low. They see it as a disruption to the day job. They don't want to take the risk of changing what they know works. To be fair to people, they may also, whether they know it or not, be trying to protect their learning curve. So I don't think we should dismiss low motivation out of hand. The key thing is to understand it. The final type of motivation is very hard, because both the organizational motivation and the organizational knowledge are low. Not only does nobody know how to do that innovation, nobody wants it either. Believe it or not, I've been there too. You might have a small number of people who see the benefit, see the potential. But if the organisational motivation is not there, then it's very hard to get the resources to make progress with it. It can be very easy for an organisation to kill off this sort of innovation, which is a risk, actually, because, as the innovator's dilemma describes, if you don't do it, a new entrant into your market who doesn't have the restriction, say, of your existing investments, they will do it. This sort of innovation, it can be ahead of its time. When the organisation gets it, then I guess its time has come. And the trick really is being the organisation that gets it first. Some organisations deal with this sort of innovation by giving employees time to work on pet projects. 3M and Google, are examples of this. But finding a way to nurture this kind of innovation without it becoming a disruption to your core business is a contradiction. And it's an issue that organisations need to grapple with and find a way through. And that's really the point of this tool. If we can recognise what kind of innovation we're dealing with, then potentially it points the way to move things forward. If organisational motivation is high but knowledge is low, then the focus needs to be on acquiring knowledge. And as I've said, collaborative research is a good and cost-effective way of doing this. Government-supported partnership with academia is a way to quickly broaden your knowledge base. But if the organisational motivation is low, irrespective of the level of knowledge, you really need to fix that first. You need to make some progress on that front, because you just won't get the resource to move things forward without it. You need to focus basically on selling the benefits of the innovation. And many inventors and innovators just are not good at the selling job. And it can be very hard work, even when the knowledge in the organisation is high. We successfully introduced a new design tool into Rolls Royce. And the critical success factor, apart from it being a good tool, was a colleague who basically just kept selling this and explaining the benefits of it to stakeholders and teams over and over again. It is easy to underestimate the effort that requires. And I think many innovations just don't happen because nobody's prepared to do that work. I'm an intuitive type in Myers-Briggs speak, okay? So to me, it's obvious that something's a good idea very often. So it was a revelation to me when I went on a course and was introduced to Myers-Briggs to realise that 70% of managers tend to be of the type who need detailed information. This explained a lot to me. And I worked with a colleague who was a master at selling innovation to parts of the business, because what he was able to do was not only explain the innovation and the benefits of the innovation in ways that they can understand, he also did it in ways that they cared about. And that's the thing that, when it comes to selling the benefit of innovation, we need to understand what the stakeholders we're talking to care about. They might care about output, they might care about quality or profit or performance. Whatever it is, we need to explain the benefits of that innovation in terms that they care about. In conclusion, I hope I've shown why innovation is at heart a contradiction, and how a learning curve contributes to that contradiction. I've introduced the innovation equation and the change equation to try and understand innovation as a process and how they can be combined together into the 9 windows of an innovation tool, which is aimed at helping us improve our innovation process. I've introduced the TRIZ methodology that can not only improve our creative capability, but also our motivation to innovate. I've also introduced innovation playing fields and how they can help us understand the type of innovation we're dealing with and how we can move that forward. And I'd like to close really by coming back to learning. I really like this quote from Peter Senge, who says, in the long run, the only sustainable source of competitive advantage is your organization's ability to learn faster than the competition. Well, I'd like to paraphrase him slightly and say that in the long run, the only sustainable source of competitive advantage is your organization's ability to innovate faster than your competition. I hope these tools and observations will help you innovate faster. Thank you. Thanks for listening.